Honors pre-calculus students, in this video I'm going to do a Newton's law of cooling example. There are several variations of this problem, but the concept is going to be the same. It's an exponential function, and the name itself tells you that the temperature is coming down. So that's very similar to the exponential decay function. So the first thing is the model is this we are looking for. T of t, uppercase T is the temperature, lowercase t is the time, m is the medium object, and e to the negative kt. Certain variation of this problem you are given very similar to this equation. If it is not given, then this basic format will be given to you. So you don't have to stress to memorize this equation. This will be given to you. The basic equation will be given to you. So let's take a look at this concept here. A cup of coffee cooled down. Cup of coffee cooled down from 96-degree temperature to 65 degrees centigrade after 8 minutes in a room of 20 degree. So many times students are really not decoding the problem correctly. There is only one sentence, but so much information is given here. So the room temperature is 20 degree. So we got the room temperature is 20 degree. T of O minus T of M. So that's a 20 degree. Medium is 20 degree, which we got that. Room temperature is 20 degree. So now, how do I know what was the object, initial object temperature? That means TO. So here we have to put these two together. This is your 1 point. You are always given a 2 point. So think about at 0, initial temperature was 90, I mean not 0, but initially the coffee was 96 degrees centigrade, and after 8 minutes, it reduces to 65 degrees centigrade. So 8 minutes, it reduces to 65. So this number will be 96. So let's simplify. 20 plus 76 e to the negative k times t. And this is t of t. If you notice that one of the class problem, you were already given this equation. They gave you this piece, and then you have to work further. This was slightly different. They did not give you this equation, but they gave you some other information. So let's work further. We have to find the value of k. To find the value of k, you are always given a 1 point. 8 T centigrade is 65. So substitute 65 is equal to 20 plus 76 e to the negative 8 times k. You must show this initial setup. Now solving for k is you are doing PEMDAS, so 65 minus 20 divide by 76 will give you e to the negative 8k. To get rid of e, we are taking ln. And k is equal to, you don't have to show much further work here, but you have to use the calculator and you have to store the value of k. So let's take a look at the value of k will be 65. Make sure you know how to use the calculator. Order of operation is important. 65 minus 20, enter. Divide by 76, enter. ln of second and answer, enter, and divide by negative 8, enter. So this is your k value, 0.0655, writing purpose 0.0655. So let's finalize our model. Our model is going to be is T of t is equal to 20 plus 76 e to the negative 0.0655 T. This is my equation. This equation I have to use to predict the temperature or predict the time. Anything. There are only two variables, T, temperature, and the time. So sometimes we ask you to find the temperature given a time. Sometimes we give you the time. No, we give you the temperature, you find the time. Any possible scenarios. Now, many students are confused. How come the K value is negative? Well, in my equation, K value is not negative, but in my equation, it's already negative K. So you cannot have a double negative, otherwise it will make positive. But look at the model. Model has a negative value, so that means exponential decay function. So let's read further. When it will cool to 25 degrees centigrade. So read the question. I don't know. You are given T of T is 25 degrees centigrade, but I don't know the time T. So for that part, substitute 25 is equal to 20 plus 76 e to the negative 0.0655 T. You can write K also. So let me show you, like I explained in the class. It's much easier if you write K. It's okay. We will give you full credit if you write KT, because you already declared your K's here. That's the same K you are using here. That the same K you should have stored in the calculator. So, did we store this value in the calculator? Nope, we forgot to store it. So I'm glad that I did not touch the calculator. So let's store alpha K. You don't have to worry about the previous K value because it always overwrites. The calculator always overwrites. So that's my K value I have already stored in the calculator. So let's come back here. 25 minus 20 over 76 is equal to e to the negative KT. Solving for T, I need to find ln of 5 over 76 divide by K. That will give you T. Oh, negative K. Divide by negative K. So let's check the calculator. We try to find the value of K. I mean a T. Start with ln 5 divide by 76. Close the parenthesis. Make sure. If you want, you can enter. So let's press enter. Now previous answer divide by negative, and our K is here, alpha K, and that's the answer. So this answer is 41.5408. Now remember, you are allowed to write 4 decimal places, but if you have to round to 3 decimal places, this 8 will become 4. So there are only 2 possible answers are acceptable, which is T is equal to, lost the time again, I mean the answer again, 41.541 or 41.5408. Only these 2 answers. Now never leave your answers bold. This is not acceptable. If anybody stops here, this will not be accepted, because we are looking for the answer in a complete sentence, in context, with appropriate unit. So I'm looking for the answer in context. Don't just write the minute here as well. This is a minutes, but this is again not sufficient. What does this tell you? 41.541 minute. What that means? What is something happen after that many minutes? We have to be very specific. So I would write a statement that after, it's a safe to write after or at 41.541 minute. This is a when part. Now comes what? What? So this is a coffee. So temperature of the coffee. Temperature of the coffee. So this is when. This is what? Temperature of the coffee will be 25 degrees centigrade. So we must have a unit, minute, both units has to be both unit, time and temperature. What? Temperature of the coffee. When? At this time. So this is very similar statement you can write. You can also say that the temperature of the coffee will be 25 degrees centigrade after 41.541 minute, or very similar statements you are looking for, but we are looking for answer in context with appropriate units. In this question, they did not ask what will be the temperature after a certain time. I guess that would be very easy, because once we find the statement here, we can easily use it. This is my model. This is the model. You can use either way you want. Now, one thing I would like to explain here is I did in the class also. Sometimes, which I'm going to go little sidetrack here, T of t is equal to, I'm using this equation here. You are given this 20 plus 76 e to the negative kt. Going little sidetrack here, that what happen if you are something like this given. And question is, find the room temperature. Find the room temperature, and you must show mathematics to justify. Use mathematics, I'm sorry, show work kind of, or says use mathematics to justify. Now you are not given Newton's law of cooling formula, you are given this. How do you find the room temperature? So you have to think of this. This is exponential decay. This is the temperature of the coffee. This equation gives you temperature of the coffee. So at some point, coffee will be the same temperature as the room temperature. If you leave it long time outside, the both temperature will be same. So what concept we are testing here is, what math is, time t approaches infinity. That's what we are looking for. T approaches infinity. What happens to this? If t approaches infinity. And for that part, we are looking for your understanding of this equation, that this is exponential decay function. E to the negative kt is exponential decay function, and we can see that when time approaches infinity, this temperature, this equation e to the kt goes to 0 because there is a horizontal asymptote at 0. So this piece becomes 0, and that makes it 20 plus 76. Sometimes students substitute infinity here. Negative k times infinity. Now, infinity is not a real number, and that's the whole reason we are using limit statement. So you should never substitute infinity here, but you should substitute the limit. By looking at this, that t approaches infinity, the whole thing becomes 0, and this is 76 times 0. This the limit statement is the math we are looking for, and that will give you 20 plus 0, which is 20 degrees centigrade. That means room temperature was 20 degrees centigrade. We are not asking for you to compare this with Newton's law of cooling formula. There are some students who are using the comparison. They are writing, I'm writing purposely here, T of m plus T of 0 minus T of m e to the negative kt, and student says, look, if I compare, I got the temperature as a 20 degree. This is not we are asking for. This is not the mathematics you are justifying. What mathematics we are looking for justification is use of limit statement. So this is the extra piece we have seen many times asked in the question. I hope this helps you to better understand Newton's law of cooling. If any question, ask your teacher.